In this question, I'm given 30.5 grams of glucose, which has that formula, and then asks me how many individual atoms of carbon would I have there. This is totally a dimensional analysis problem. So what we're going to do is begin with the value that we've been given. 30.5 grams of glucose, and I'll go ahead and write out its formula, C6H12O6. And then I'm going to do a bunch of parentheses in order to manipulate that into eventually getting to atoms of carbon. So I want to do a bunch of parentheses until I get to something that has units of atoms of carbon down at the other end. So I'm going to go ahead and put down a set of parentheses, and I'll write down grams of C6H12O6. Okay? Now what could I possibly put in that set of parentheses? Is there anything that I know of that has grams in it, some type of thing, something per gram or grams per something? Well, yeah, I could say that 1 mole of C6H12O6 has a certain number of grams. That's a formula or molecular weight of glucose, couldn't I? Okay, let's go ahead and do this now. So obviously I'm going to do another set of parentheses because I cancel out the grams of glucose there, but I'm not left at atoms of carbon. I've got moles of glucose up here, so in the denominator here I'm going to use the same units, moles of glucose. Now what am I going to put in the top? Well, I'm trying to focus in on moles of carbon. Could I put moles of carbon, I'm trying to get on toward carbon at least. Could I put moles of carbon in the numerator? I think I probably could. Maybe I could interrelate those two if I've got 1 mole of, yeah, okay. Okay. Now that doesn't get me to individual atoms of carbon yet, so I'm going to have to put another set of parentheses, and I can put moles of carbon in the denominator, and then I'll go ahead and put atoms of carbon. Can I interrelate moles of carbon to atoms of carbon? Now, of course, I've run out of room, so I have to write sort of diagonally up the side. That's kind of embarrassing, but you know, it's what we have to do. Let's see if we can figure this out. So if I look at the molecular weight of glucose, we'll start with that easy one there. Carbons weigh 12 each, hydrogens weigh 1 each, and oxygens weigh 16. So doing the math, I can determine that the molecular weight of glucose is about 180 grams. Now here's the confusing one. If I have 1 mole of glucose, how many moles of carbon do I have? Well, that might be a little bit confusing. I want to simplify it here. I want you to imagine that you have 1 single molecule of glucose sitting in your hand. Just one. 1 molecule. How many carbon atoms are in it? Well, yeah, there are 6 carbon atoms. So if I'm holding a single molecule of carbon, or of glucose, I'm holding 6 carbon atoms. So if I've got 6.022 times 10 to the 23rd molecules of glucose, how many atoms of carbon do I have? Well, I've got that number times 6. So in other words, because there's 6 carbons per glucose, if I got 1 mole of glucose, I'm going to have 6 moles of carbon atoms sitting there. Hopefully you're okay with that. So I'm going to go ahead and write down 6 moles right there. Now let's see if we can convert moles of carbon, sorry, I'll put carbon right there, into atoms of carbon. If I have 1 mole of carbon in my hand, how many atoms of carbon am I holding? Well, yeah, you guessed it. It's Avogadro'S number, which is 6.022 times 10 to the 23rd. So once again, 1 mole of carbon contains 6.022 times 10 to the 23rd atoms of carbon. Now if I've done this correctly, I think that my units are going to cancel each other out. I've got moles canceling out with moles, moles of carbon canceling out with moles of carbon, and I'm left with atoms of carbon, which are indeed the units I'm trying to get toward. So just throw that into your calculator, plug and chug, and you should get the right answer to this question.